In this video, we are going to look at the cosine rule and area rule. So let's first begin by drawing a non-right angle triangle. So like sine rule, cosine rule can be used whenever you are given a non-right angle triangle. So let's say we have A, B, C. So our first step is first we need to indicate the distance according to its angle. So this distance here will be small letter A, then this distance here will be small letter B, then this distance here, this is our small letter C. Now let's say our angle of consideration, our angle theta is on letter C. So let's first look at how can we form the formula if we are solving for the distance AB. So for you to know that you are going to use the cosine rule, you are going to be given two distances and one angle. Then the task is you find the third distance. So let's look at the formula. So the first letter should be the distance that you are solving for, or the distance corresponding with the angle that you are solving for. So it depends with the need of the question. So in our case, we are solving for the distance AB. Under AB, we have this C. So it should be C squared is equal to, then the other two distances are A and B. So we have A squared plus B squared minus 2AB. Then cos, the first letter is our C. So this is the angle, the formula for cosine rule, provided you are solving for a distance. Also, this formula can be used if you are solving for the angle. Now, if you are solving for the angle, you are going to be given all the three distances. Then let's look at if the question now comes, you find the area of this triangle. So the area is equal to half. Then we need to have the two distances that are making the angle. See, in our case, we have this distance and this distance. So this is our two distances that we need to put in consideration. So these two distances are denoted by A and B, then multiplied by the sine, what angle theta is on C. So this is the formula for the area of a non-right angle triangle. Now this formula can be used to calculate any triangle. So now let's look at the first example. So the first example, the diagram below shows a triangle KMN in which KM is equal to 8 kilometers, MN is equal to 10 kilometers, and angle KMN is equal to 92 degrees. So the first question is find the distance Kn. So we are solving for the distance Kn. So let's first look at the letters. So here we are going to have the small letter M, then this one is small letter N, then the 10 kilometers is small letter K. Now what did we say? We said for us to know that we are going to use the cosine rule to find the distance, the two distances must be given and one angle. And we can see that we have been given two distances, the 10 kilometers and 8 kilometers and one angle. So we are going to use the cosine rule. So let's now write the formula. So the formula is m squared, since the m is on the distance that we are solving for, which is Kn. M squared is equal to K squared plus N squared minus 2Kn cos the first letter, capital letter M. Now let's substitute. M squared is equal to our distance for K, we can see is 10 kilometers. So 10 times 10 plus C. For N, we can see that we have 8 times 8 minus 2, here we have 10, then 8 cos 92. So now let's expand. 10 squared is 100 plus 8 times 8, that is 64. Then let's calculate 10 times 2 times 8 times cos 92. So I'm getting positive 5.58339. Then we can now add the all three numbers, so plus 64 plus 100, so this is equal to 158.4. so let's say 16. Then what are we going to do? We need to find the square root on each side. So here we can cancel. M is equal to, so the square root answer is equal to 12.58, so which is 12.9 kilometers. So this is our distance that we are solving for. Now let's move on to the area of triangle KMN. So now we can see that we have the all three distances, but you need to be very careful here. You only need two distances for you to calculate the area. So the distances that you are supposed to use are those that are forming the angle. So in our case, we are going to use the distance for K and the distance for N. We can see that these two distances are the one forming the angle. So let's now look at the formula. Area is equal to half the two distances that are forming the angle are K and N. So we have Kn, then sine, our angle is on M, so sine M. Then area is equal to half, distance for K is 10 kilometers, N that is 8 kilometers, sine 92. So what I'm going to do is I'm going to multiply the numerator. So 10 times 8 times sine 92, I'm getting 79.951266. I'll just write it squared over 2. So where the squared is coming from is kilometer times kilometer, or area should have a squared. So the final answer now divided by 2, I'm getting 39.96 kilometers squared. So this is how we can find the distance using cosine rule and the area. So let's look at another example. Okay, so example 2, the diagram below shows the location of houses for a village headman, his secretary and a trustee. H is 1.3 kilometers from S, T is 1.9 kilometers from H, and angle THS is equal to 130. Then the first question is calculate distance TS. Now feel free to pause the video so that you can give it a try. Then after that you can compare your answers with mine. So what do you think are we supposed to do? Well, so what we are going to do is first we need to indicate the distance with its corresponding angle. So our first point is this distance here is small letter h. Then for this one, small letter t. Then here we have small letter s. Then after that, let's write the formula. So the formula is h squared is equal to s squared plus t squared minus 2st cos h. From there, h squared is equal to, what's our s? The distance for s is 1.9 squared plus 40, where I can see it's 1.3 squared minus 1.9 times 1.3 cos 130. So h squared is equal to, so 1.3 squared 1.69 sorry, this should be 1.9 squared. I wrote 1.3 squared, so 1.9 squared 3.61 plus 1.69. Okay, so let's say negative 2 times 1.3 times 1.9 then equals 130. So I'm getting positive 3.175. Then we can now add, so 3.175 plus 1.69 plus 3.61, so this is equal to 8.475. Then we need to look for the square root, so square root here, so our final answer h is equal to, so the square root of this answer is equal to 2.9 kilometers. So this is our answer. Now let's move on to the area. So the area is equal to half. Then the distances that are forming the angle are S and T. So ST sine H. So area is equal to half. What is our distance for S? 1.9. Then for S, 1.3 sine 130. So let's multiply the upper part. 1.9 times 1.3 times sine 130. So I'm getting 1.892 kilometers squared, then divided by 2 was our final answer. So my final answer, I'm getting 1.24 kilometers squared. Okay, so now let's look at another example. Okay, now we move on to question 3. In triangle ABC below, AB is equal to 275 meters, AC 45 meters, and BC is equal to 300 meters. So we have this triangle. Now remember, we say the first step is we need to first indicate the small letter z corresponding to its capital letter angle. So here we get small letter C, here small letter A, then here we have small letter B. Now what is our first question? So the first question is we are solving for angle BAC. So this means that the angle is located on the middle letter. So in our case, our angle that we are solving for is this one. Now from the question, we can't tell whether we are using the sine rule or cosine rule. So how do you know that we are using the cosine rule to find the angle if you are given all the 3 distances like the one that we have this example? So now let's look at the formula. So like the same way we did, first we need to look at the first letter that is corresponding to the angle that we are solving for. In our case is a squared is equal to, so we have b squared plus c squared minus 2bc, then cos A, since we are solving for angle A. Now this time our distance for A is 300 meters. So squared is equal to b 45 squared plus our c is 275 squared minus c, our b 45, our c 275, then cos A. So 300 squared is 3 times 3, which is 90, so that is 90,000. Then 45 squared, this should be 2025. So 45 times 45, okay, 2000. 25 plus then 275 times 275, so I'm getting 75,625 minus, so 2 times 45 times 275, I'm getting 24,750 750 cos A. Now upon reaching here, what do you think can we do? Well, so what we are going to do is we are going to add the 2025 plus 75,625, so our 90,000 will just read it like this. Then we can add 2025 plus 75,625, so I'm getting 7,650 minus 24,750 cos A. So what are we going to do? We are going to collect the like term. So our point is we are trying to isolate cos A. So 77,650 will shift to the other side, giving us 90,000 minus 77,650 is equal to negative 24,750, then cos A. So we can now do subtraction. So 90,000 minus 77,650, so I'm getting 12,350 is equal to negative 24,750 cos A. Now since we are solving for cos A, what do you do here? So we divide by negative 24,750, even here negative 24,750, so that if we cancel, we get now cos A is equal to, so 12,350 divided by 24,750, so I'm getting negative 0.89899899. So since we are solving for angle, what do you do? We shift this cos to this side, giving us now A is equal to cos of inverse of negative 0.49898999. So on the calculator we can press shift, then answer. Okay, so shift cos negative 0.4 0.98989899. So I'm getting 119.93. So our final answer, we can round off our final answer to the nearest 100. So in our case, to the nearest whole number. So this is 120 degrees. So this is the angle here. So we have an angle of 120. Then let's look at the area. So area is equal to half. So the distances that are forming the angle 120 is BC, then sine A. So half, our distance B is 45, our C is 275, then sine 120. Then we can now simplify our final answer. 45 times 275, then sine 120, so 10,717.0643 meters squared over 2. So our final answer area is equal to 5,358.5 meters squared. So now you have an idea, or maybe we can say from what you know, we've added at least some information on how to use the cosine rule and the area rule to find the distance angle and the area of a non-right angle triangle. So if you find this video informative, please give it a thumbs up, and don't forget to share, like the video, comment, and thanks for watching.